you know that at the end of 2022, 2.9 billion people, almost one-third of the planet population, have not access to the internet? They are low-income people that live on poor or developing countries mainly. This denial of access denies the people opportunities, equal opportunities to work, to learn, to have access to the information. So there is a challenge how we can provide internet broadband connection to those people. Internet requires means to provide signal to the user. Usually you have cable, fiber, or radio. Those infrastructures are expensive to install and maintain, and even have difficulty with the distance range. So this difficult to provide internet broadband to remote locations. In fact, this creates a real internet broadband desert on the world, where internet access simply does not exist.
For most remote and underserved communities, the communications challenge is the lack of infrastructure, having the physical towers and cabling to reach homes. What is called the last mile in the USA. Without this access, it is impossible for people to work from home, for kids to attend school, do homework, or to use telehealth. And so to adapt and respond to this challenge, we're seeing now the use of satellite constellation systems. The development of these constellations in lower Earth orbit is now providing coverage and capability for people to connect to the internet and expand their ability for people to live and work anywhere and to connect remote and rural communities around the world.
Satellite broadband has been something that's been tried in the past more than once. We think of space as right above our heads when in fact it's tens of thousands of miles above our head. And when you are talking about building a network up there, it requires a lot of engineering effort. Putting the satellite into orbit, connecting the satellite back to the ground or to other satellites. You can't do service calls. You can't send a truck up to fix a satellite if something goes wrong. And so those are just some of the challenges that go into building the network. The other issue that you get into with space is that if you think about it, imagine that you're a satellite above the Earth's surface and you're talking to subscribers on the ground. You can see hundreds, if not thousands, tens of thousands of square miles simultaneously. Every subscriber in that footprint is going to be trying to talk back to that satellite, reasonably speaking. How do you handle all of that incoming traffic and deal with it appropriately? The reality is that it requires a lot of computing power. And as Moore's law of semiconductors has evolved, we have greater processing power in semiconductors now that have actually begun to allow us to build space-based communication systems that can handle the amount of traffic and separate all of those signals out into usable streams that can be individually processed and take those signals to where they need to go. Satellite broadband systems help to connect remote communities because it does not require infrastructure to be built from urban or suburban areas out into rural communities. The satellites pass over every point on the globe, and as they pass over, then a connection can be established down to the ground, and the subscribers in those remote communities can receive the same level of signal that they would receive from that satellite if they were in the middle of a major metropolitan area.